During this webinar, if you have any queries, you can contact us on WhatsApp number, which I will share in one of the next slide. You can follow us on these social media sites for recent news, updates, and application and training related videos. Before starting with the technical presentation, I would like to brief you about Anchrome. We are official distributor of CAMAG Hptlc instruments from last 40 years. And we provide free Hptlc training at Anchrome Lab in Mumbai since 1994. If you have any queries, as I have earlier said, you can contact us on lab@anchrome.in, or you can call us on this WhatsApp number. We provide free training to all government employees, PG and PhD students and their teachers at our Hptlc research lab in Mumbai. Training can also be arranged in your city if it is not possible for you to come here. Dates can be decided by mutual convenience, and we issue certificate after training. Until now, we have trained over 5,000 Indian scientists since 1994, and we have signed MOUs with several prestigious universities and institutes for collaborative work. This is the link of this is the slide which represents that we have the image of the Anchrome YouTube channel on which we have uploaded various tutorial videos on WinCats and VisionCat software. If you are interested, you can search Anchrome on YouTube and you will get free access to all these videos. Now let us start with the technical presentation. Before starting with the Hptlc, now let us understand how Hptlc has sorry, evolved from TLC. In 1960, there used to be manual TLC. There were no instruments at all. Then the instruments were introduced, but those were very simple instruments. There was no control on how much sample you are applied on your plate, how you are developing your plate, in what humidity conditions you are developing plate. There was no control on anything. Therefore, people used to get a lot of variation in the result. Then the software was introduced, which would control all these instruments. But still people used to get a lot of variation in the results, although we had software and instruments. Because suppose I am applying, I'm doing one analysis for particular sample and I am applying a band of 3 millimeter. You may apply band of 6 millimeter for the same sample. There was no uniformity in how I should apply the sample on plate or many other things. Therefore, still, although there was software and instrument and software controlling instrument, we used to get a lot of variation in the result. To avoid this or to bring standardization in the system, Hptlc methodology was introduced in 2016, and now it is official in United States Pharmacopoeia from 2018. Now we have instruments, now we have software control instrument, we have system which is GLP compliant, we have standardized methodology, and this methodology is standardized by United States Pharmacopoeia, which meets all the which meets with the regulatory compliance. And the future of Hptlc is Hptlc Pro, which is robotic Hptlc, in which manual steps are completely removed, everything is automated. Now with this slide, you can understand a difference between TLC and Hptlc. On the right hand side, I have an image of TLC, a TLC analysis of Asian ginseng. Now, if you, 1 minute, let me share it in full screen mode. Okay. On the right hand side, I have an image of TLC analysis of Asian ginseng. On the left hand side, on this image, you can see that there is one standard. This is standard, and along with that, there are 3 different samples. Now, and one must have done this by using capillary tubes. Sample has been applied in the form of spots. Then you have to sit there all the while until it reaches the solvent front. And this is the result after derivatization. Now, this is my standard, which has migrated to this distance, maybe 0.5 or 0.6. Now, if I ask you whether this is same as this or whether it is present in the samples which are applied along with that, it would be difficult for you to conclude, because you can see that there is no proper separation. There is a lot of mass of unseparated compounds. It is difficult to identify whether this is same as this. Now, if I am subjecting same sample under Hptlc conditions, see what happens. Here, the major difference is instead of applying my sample in the form of spots, I have done application in the form of bands. Here, I could merely apply one standard, but in this case, in Hptlc, we have applied 5 different standards. And along with that, there are many different samples are there. And you can see that we have got much better resolution. We have got base to base separation between the bands. We have got separation up to the solvent front, and it is easy for us which all standards are present. It is easy for us to identify which all standards are present in my samples. I can go for quantification, identification as well as quantification. So this is the difference between classical TLC and modern day Hptlc. Now, if you see most of the pharma monographs which are there for TLC, they say that use 20 by 20 centimeter plate, run that plate up to 13.5 centimeter or 14 centimeter. So what we have done is we have miniaturized the size of the plate. Instead of using 20 by 20 centimeter plate, we are using 20 by 10 centimeter plate. We are running those plate up to 62 millimeter or 70 millimeter if we are considering the position from the base. And you can see that we have got much better resolution than 20 by 20 centimeter plates. Band separation is good. Bands are much sharper, and we have got nearly same results as that of 20 by 20 centimeter plate. And these 20 by 10 centimeter plates, they require less solvent. Only 20 ml solvent is required. We can complete the analysis in less time because the run time is development distance is less, only 62 or 70 millimeter. We have got sharper bands, and at the same time we can apply more number of samples. Now, this slide represents complete Hptlc system and the data output which you get from each of these instruments. Hptlc technique is a stepwise technique. You have to follow certain sequence while going for Hptlc analysis. There are different instruments for different steps. Applicator is there for application, developer is there for development, visualizer is there for photo documentation. By using scanner, one can go for identification and quantification or further validation. Now we have we can connect Hptlc with the mass analyzer by means of MS interface, and we can go for derivatization as well. We are going to see in detail about each of these instruments, and this is the data output which you get from each of these instruments. Then we have this VisionCat software, which is latest one, which controls all these instruments or which manages the workflow of your analysis. Now, if we talk about Hptlc quantification, yes, Hptlc quantification is possible because scanner is there. We can use standardized methodology, or we can standardize our own method which we have developed. We have software controlled hardware. If your compound is showing UV absorbance, you can go up to nanogram or ppm level, and if it is showing fluorescence, one can go up to picogram or ppb level. Reproducibility, scanning reproducibility is plus minus 2%. Accuracy and precision is high, and we can go for multiple detections without repeating chromatography. We will elaborate this point in one of the coming slide. As I have mentioned, nowadays MS hyphenation is also possible, and the system is fully regulatory compliant worldwide. Now, if we talk about Hptlc fingerprint, you must have heard this term many a times, or you might be developing a fingerprint for your samples. This term is majorly used for the analysis of herbal samples, fingerprint term. Now, what is the United States Pharmacopoeia definition of Hptlc fingerprint is that it is the electronic image of the visual Hptlc chromatogram. That means after doing sample application and developing it in suitable mobile phase, you are supposed to take image by using suitable device, and you're supposed to take images at 3 different illumination modes, that is 254 nanometer, 366 nanometer and white light. And you are supposed to evaluate your Hptlc fingerprint based on RF, color, and intensity of bands. That means, suppose if you have got profile something like this for your sample, you are supposed to record its RF value. What is the RF value? Retardation factor value. What is the color of the band which you have got, and intensity. Intensity is subjective. You can consider the highest intense band. For example, in this case, this will be highest, this or this will be the band which will be showing highest intensity, and accordingly you can decide intensity for the other bands. It should account for 100% of the sample, and for comparison you can use botanical reference material or BRM. That means you are supposed to use authentic sample, or you can collect the sample from the field, or you can collect it from the market, but get it authenticated from the recognized botanical institute, and that you can use as botanical reference material, so that you will have an idea what is the authentic fingerprint. And if you have many other samples which are collected from market or many geographical location, you can see the difference or the variation in the results, whether it is same or it is showing some different pattern. This is one example for Hptlc fingerprint. This is an example of different species of pepper, which is a famous example is black pepper, which we use as spice. There are different species like nigrum, longum, retrofractum, cubeba, bourbonense, etc. On the left hand side, you can see we have applied different standard, and along with that there are different species. Now if you see this image carefully, you may find that there are some bands which are common in all these fingerprints. For example, this one, because all these plants belong to same genus, that is piper, but there are some bands which are present only in that particular species. For example, this orange color band is present only in piper cubeba. This you can consider as its marker, or you may call it as analytical marker, because you might not be having information what is its biological or therapeutic activity. Then in that case you can call it as analytical marker, and this band you can use for its identification. This is how you can develop and evaluate your fingerprint. Now we will see the major difference between TLC and Hptlc. In TLC, the primary focus used to be simplicity and low cost. Earlier, people wanted to have fast results on benchtop, so they would use TLC. They will apply the sample on the plate. Suppose somebody is working on some synthetic reaction mixture, he would take out the sample from the reaction vessel, and suppose A and B is my reactant and C is my product. One used to expect that, okay, if A and B is getting reduced and C is getting intense, that means, okay, my reaction is going to complete. So this is how people used to interpret results from simple TLC. But in Hptlc, our focus is on reproducibility and separation power. We should get good results with baseline separation, good resolution for the separated bands. And suppose I have developed some method, I'm transferring that method to some other lab, or I am doing same analysis after 2 days or 3 days or any other time, I should get same reproducible result. So this is possible by means of Hptlc, because we have a highly standardized methodology with optimized parameters. In TLC, the target used to be rapid and preliminary results, but in Hptlc, our focus is on reliable analytical results. Hptlc technique, it's simple, reliable, fast, and safe. It is very easy to learn. You can apply many number of sample at the same time. 15 to 18 samples can be applied at the same time, and you can generate the report or do the analysis in 1 to 2 hours roughly. There is ultra low running cost and maintenance. There is no special requirement of temperature and pressure, except nitrogen or air which is required for the application, and the plate heater which is required after derivatization. There are multiple detector eyes, electronic and bioactivity. That means, or these 2 points are same, or we can collect huge data about samples. That means after going for one single analysis, you can record your results in UV, invisible, in fluorescence range. You can take spectra for its confirm identification. You can go for derivatization. You can send your sample for mass analyzer, and bioactivity studies are also possible. Now we will see how HPTLC is carried out. For my first step will be sample preparation. After that, application on plate. Once application is complete, you are supposed to develop your sample in suitable mobile phase. Then you can go for image documentation, and after that densitometric scanning. And scanning is non-destructive technique. After that, you can go for other characterization studies like MS, IR, NMR, or you can go for derivatization. And after derivatization, again, you are supposed to take images and you can go for scanning. Now we will see some of the features of CAMAG HPTLC system for QC and research lab. HPTLC system comprises of series of independent instruments. We have seen it one of the slides, which are controlled by one software. Because of this, up to 6 to 10 analysts can use one HPTLC simultaneously. We are a team of 14 people in our lab. If suppose one is doing application, some other can go for development, some other can go for scanning. This is how many people can work at the same time on same system on different projects without interfering in each other's work. And the system is easily upgradable. If you have semi-automatic applicator, one can go for automatic one, or if you are using twin trough chamber, one can go for automated development chamber. We have database oriented software for QC. What does it mean is, suppose I'm working on some sample, say for example Piper sample, and I want to see the results of all the analysis file which I have created in last 6 months. That is possible because we have SQL database software. You are supposed to type just piperin in search tab and you will get access to all the fan analysis files which have been created over a period of say 3 months or 6 months. And each analyst work is password protected, which is easy to track, search, collate. You can compare the result, you can generate reports, and there is multi-level security of data. There is minimal use of solvents. Only 30 to 20 ml mobile phase is required for 15 to 20 samples. You can use cheaper AR or GR grade solvents, which are half of the price of LC grade solvents. The system and the method is very economical, very little waste is produced, and you can perform analysis on demand. You can apply any sample, any organic non-volatile sample on plate, and you can directly put it for application or further analysis. Even though you do not have any information about your sample, it is not going to damage your system or anything else. At the most, what will happen is, suppose if you do not have any information, and then also if you are applying that sample on your plate may get your analysis may fail, or your plate may get degraded. It is not going to affect your system. There is no separate preparation time. There is no disturbance to other users, and you can generate report in 60 to 90 minutes. I'm facing a lot of disturbance from the background. Hello?
Sorry. You can cut.
Yes. And we provide trustworthy anatomy support since 1978. If you have any problem in method development or you have got stuck in between analysis, we are there to help you. whether it is service related support or analysis related support. Now we will see regulatory acceptance of HPTLC. As I have mentioned, HPTLC is now official in United States Pharmacopoeia. There are different chapters like 203, 621, as I have shown on this slide. There is chapter 203, which is official from 2018, which talks about HPTLC methodology and fingerprint identification of materials of botanical origin. That means it is applicable for all the samples which are prepared from herbal ingredients. That means you can follow all the guidelines or all the standardized parameters which are given in this chapter for the analysis of herbal ingredients by HPTLC. There is USP chapter 621, which mentions the use of scanner for quantification. There is USP chapter 202, which is there for identification of fixed oils, in which they have developed or standardized the method for analysis of 14 different oil samples. There is USP chapter 2251, which is there for identification of synthetic API in herbals. And there is USP chapter 1064, which talks about parameter selection explanation. That means if I'm going to do analysis by HPTLC, what are the parameters I'm supposed to apply while going for sample application on my plate. That is all explained under chapter 1064. And now this technique is also official in European Pharmacopoeia. There is chapter 2.8.25, which is very much identical to USP 203. And soon it will become official in Indian and Chinese Pharmacopoeia. In WHO, it is already official. Now these USP, what are the essential requirements for QC as per USP? There should be fixed sample application position and band length. The application and the development should take place under controlled condition by using suitable device.
Network कुछ problem हो रहा है. Net का कुछ हो रहा है.
Hello. Is anybody facing problem with the network? Okay, I'll continue. And one can use scanner for quantification, and each of these devices are IQ, OQ, and PQ qualified. Now this chapter, United States Pharmacopoeia chapter 1064, talks about parameter selection explanation. That means it has standardized how I should go for sample application. What should be the band length? How much distance I'm supposed to leave from the x-axis? How much distance should be there for the y-axis? At what length I'm supposed to apply my sample on plate? What should be the development distance? Everything is standardized. And when you are following all these parameters, you get reproducible results every time you repeat particular analysis. Now let us take a look at HPTLC Pro, which is latest system. Although these, you can see those blue color, and the focus of the system is on automation, high throughput, and reproducibility. We'll see how it works. We have two videos in our lab. sample applicator and development module. You can give program for 5 different plates at the same. This is how you can understand how it works. Until now, they have launched only 2 modules, applicator and development module. Soon they will launch other modules. Now we will see CAMAG Hptlc regulatory compliance. It is 21 CFR Rule 11 compliant, which talks about auditable data and electronic signature for the authenticity of the data and the method and the system. The Hptlc system is GLP and GMP compliant. All it is IQ, OQ, and PQ qualified. All the data is stored in encrypted and password protected database. You don't have to worry about safety of your data. You can set the digital signatures up to 5 levels, and user access control can be given up to 7 levels. Full audit trail for analysis and system is there for users and instruments as well. You can take the log of who has, you can get the log in which you can see who had started the instrument, what all files or the analysis has been carried out on that instruments, what changes has been made in method file or in analysis file or in results. Everything is recorded, so there is no chance of any manipulation. That is why it is much preferred in pharma industries, and you can schedule automatic backup with automatic backup tool, and it complies with latest regulations. Now, United States Pharmacopoeia has made its sample preparation very easy. If you are dealing with herbal sample, take 100 milligram of the sample, powdered sample, dissolve it in 1 ml methanol, sonicate the same for 15 minutes, centrifuge it at 5000 RPM for 10 minutes, and you can use supernatant directly for application. It has made sample preparation very easy and economical. There is no need to go for solvent extraction or oxalate extraction, which takes lot of time and uses lot of solvent. After sample preparation, we can go for sample application. Majorly, we have these 2 options available. I will not talk about Pro, and this one is automatic applicator. Both these instruments, they work on spray-on technique. That means nitrogen or air is required for the application. What happens is your sample gets mixed with the nitrogen or air, and it is converted into a fine mist, and this mist is sprayed onto the plate in the form of thin, sharp bands. Only difference is there in automation. Otherwise, the quality of bands which you get by both of these instruments will remain same. The only difference is, as this is semi-automatic applicator, syringe rinsing, feeling, mounting, all these steps are manual, though, so that the analyst will remain engaged with the instrument while performing application. Whereas all these steps, that is syringe rinsing, application, mounting, syringe is fixed on the instrument, all these steps are automatic, so that you can put your samples in the vials on this tray. You can put your plate on this stage, and you can give command to the instrument, and you can go plan some other work. Once sample application is finished, it will give you a message that, okay, sample application is done successfully, and then you can go for the development. When it comes to Hptlc sample application techniques, there are many types of sample application techniques. In that way, it is very much flexible. The most popular one is quantitative one. If we want to quantify how much amount of standard is present in your sample, one can go for this type of program, quantitative, in which we apply 3 to 5 levels of standard or 3 to 5 bands of standard, and along with that we can apply different samples. The software will plot calibration graph and it will tell you how much amount of standard is present in your sample. In situ cleanup technique is used to remove fatty matrix from the sample. If you are facing interference from the fatty matrix, you can use this technique. I will not talk in detail about this. If anybody has any queries, we can take it at the end of the presentation. If they want to know more about it in detail about this technique, then we have micro preparative isolation. Suppose you are interested in one of the band or analyte. Say for example, if you are working on Phyllanthus emblica amla sample and you are interested only in gallic acid or ellagic acid, you want to isolate it, you want to use it for formulation, or you want to send, or you may want to send it for further characterization studies. In that case, you go for this micro preparative isolation, and superimposing technique is used, in which you can apply sample or standard on the already applied band. This is used mostly for the recovery studies, which is one of the parameter of validation studies. After sample application, we can develop the plate in suitable mobile phase. For that, we have three major options available: twin trough chamber, auto development chamber, and gradient elution chamber. Twin trough chambers are most popular, most people use it. But if you want to comply with GLP requirement, in that case, one can go for ADC. And when you are dealing with very complex samples having multiple polarities, in that case, one can use a gradient elution chamber. If we talk about mobile phases in HPTLC, very little consumption is there, only 20 to 30 ml for 15 samples. That means only 2 to 3 ml per sample. Any combination of stationary phase and mobile phase is possible. No, there is no separate preparation time, no degassing is required. Readily you can mix the solvents in that particular proportion, and you can run your applied plate in that particular mobile phase. If we talk about gas phase comes in picture in HPTLC if we are giving saturation to the chamber. 20-minute saturation time is essential, and we can control the humidity at 33% if we are using saturated solution of magnesium chloride. Now, if we talk about stationary phases in HPTLC, mostly silica gel 60, F254 or RP18 plates are used, which works for most of the sample, 90 to 95% of the sample. And we have ready-made HPTLC pre-coated plates available, which are available in the sizes of 20 by 10, 20 by 20, 20 by 10 centimeter, or we can cut it accordingly as per our requirement or depending on the number of samples. This is automatic chromatogram development chamber, ADC or ADC2, which is used for isocratic development, which is compliant with United States Pharmacopoeia and all the important steps of the development, that is plate development, chamber saturation, plate drying. Everything is done automatically by this instrument. And the most important factor is, as HPTLC is open system, we get variation in the result, although we may get variation in the result, although we are following same methodology for particular sample. Because suppose if I do not have control on humidity and I'm performing one particular analysis, because of the changes in or the variation in the humidity level, I'm doing one particular analysis in Mumbai, I may get different result if I am performing same analysis sample in Gujarat, and the result be on humidity. Control this development chamber is introduced, in which we can control the humidity by, if we are using exposed to the vapors of this salt, and then it is sent for development. That means all the important steps of the development, that is chamber saturation, plate drying, plate development, everything is controlled by the instrument. Plus we have control on environmental conditions. Basically we are trying to remove here operator error as well as the errors which are caused by the environment. If we are dealing with very complex samples having multiple polarities, you can use this AMD2 instrument. This is the image of the instrument, and you can see they have given 5 different bottles in which you can keep different solvents from polar to non-polar, or you can keep 5 different mobile phases, and you can set the gradient up to 25 steps. Now, how we can set the gradient? Suppose I have 20 by 10 centimeter plate or 10 by 10 centimeter, 20 by 10 centimeter plate. For first 5 millimeter, I can use combination of some of the mobile phase out of these 5 bottles. Suppose I'm taking toluene ethyl acetate for first 5 millimeter. For the next 5 millimeter, I can use some other combination. Toluene ethyl acetate methanol 7s to 3s to 1. So this is how you can develop the plate at different development distance up to 25 steps by using solvents which are given in these 5 bottles. And once you give program in the software, it will automatically mix the solvents out of these bottles, and then plate is run up to the desired distance in that particular mobile phase. So this is how you can set the gradient. This is one example in which you can see how we have separated one of the difficult compound which was structurally same. It was differing only in one methyl group. It was difficult to separate, but by using this technique, it can be separated. For that purpose, you can use universal gradient, which is based on dichloromethane. That we had 3 compounds basically, 1, 2, and 3. 3 is already separated one. It was difficult to separate 1 and 2. When we have used a gradient which is based on dichloromethane, that means to run that particular compound, we have used solvent on dichloromethane. In the next run, we have used the gradient diisopropyl ether. When we use dichloromethane, we could not see any separation for compound 1 and 2. But when we use diisopropyl ether, you could see that we have got separation for 1 and 2, but they are not completely separated. So what we have done is, in next run, we have extended this run only, which is based on diisopropyl ether. So when we have used diisopropyl ether for this next successive runs, we are able to separate it completely. You can see baseline separation is there, 1 and 2 is completely separated. And this is how, by using different gradients, you can even resolve or separate the compounds which are difficult to separate by other techniques. This is one example of separation of phospholipids and ceramides, cholesterol, and fatty acids from stratum corneum or human skin by using this technique AMD2. For more details, you can refer these application notes. After development, after application and development in suitable mobile phase, one is supposed to go for photo documentation at 3 different illumination modes, that is 254, 366 nanometer and white light. Now, HPTLC is the only chromatographic technique which allows you to record your results in the form of pictures at these 3 different illumination modes, and this works on HDRI technology. What it does is, it will capture images at different exposures, and it will digitally combine all these images to give you properly exposed image, in which you can see the lightest band as well as the brightest one at the same time. Because in your compound, especially if it is herbal one or food sample, there might be some compound which are present in less quantities, there might be some compound which are present in high quantity, but you should be able to see all those compounds in one image only. This is possible because in this instrument HDRI technology is used, and CAMAG is the only company which is using this technology for photo documentation. Then we have one more option is there, that is comparison viewer in the software. By using this option, what you can do is, suppose if you are working on curcuma sample, you are working on it from the last 6 months and you want to compare the results of all the analysis files. Suppose you have used different mobile phases, or you have collected sample from different geographical location and you want to select which mobile phase or or what sample from which geographical location is best for my analysis. In that case, what you can do is you can get or place the tracks of all those analysis files on the same screen side by side, and you can use it for better understanding for your results. Here we have track of 49 different samples, and these tracks belong to different plates of different samples, the analysis which was performed on different days in different labs, or maybe on different species, and the analysis is performed by maybe by different analysts. So you can place the images of all these analysis files or the samples on the same screen side by side, and you can understand which sample is good for your analysis, or what sample is giving you best results. We can go for quantitative evaluation by Hptlc. In TLC it was not possible, but in Hptlc it is possible because we have scanner. Latest version is scanner 4, and this is the data output which you get after scanning. That means after going for scanning, one can go for confirm, identification and quantification and further validation studies. You can record results for your sample at 3 different illuminations, that is UV, visible and fluorescence mode. For that purpose, it has 3 different lamps: deuterium, mercury and tungsten lamp. Deuterium is there for short UV, tungsten is there for visible light, and mercury lamp is there for fluorescence. The scanning range is from 190 to 900 nanometer, which covers all these regions: UV, visible and fluorescence. Fully automatic scan is possible, and plus you can go for taking spectra. As you can see over here, you get very sensitive and reproducible results, and as it is non-destructive measurement, you can send your sample for further characterization studies, or you can go for bioactivity studies as well. This is the chromatogram. These are the images for spectra. This is the calibration graph, and this is 3D chromatogram, by which you get an idea about your samples and standards. Now, what happens in scanner is a beam of monochromatic light moves along individual tracks of the plate, and the amount of light which is coming back from plate to detector is measured by a photomultiplier tube. Signal is amplified and it is converted into peaks like this. This is how you get peaks and the area under the peak for your particular band, which you have separated on your TLC or Hptlc plate. We can go for spectra or for confirm identification of that compound. Our spectral range is 190 to 900 nanometer. These are the different spectra for different compounds: sulfomethaxole, trimethoprim and dimetridazole. You can see over here, all these compounds are showing different lambda max values, and their spectral pattern is also different. So this is how you can go for identification of one particular compound by taking spectra. If you are once one spectrum per band will tell you about its identity. Suppose you have separated some band on your plate, say for example caffeine. You have applied standard caffeine and some sample on your plate. You have got same RF value which is matching with caffeine standard, but still you may not be sure because it might be some other coeluting band which is coming at the same RF. In that case, you can take the spectra and you can confirm result if both the standard as well as the sample or the band which is coming in sample at the same RF as that of caffeine, if they are showing same spectral pattern, same lambda max value, then you can say that yes, the bands which I have separated is caffeine only. You can check for its purity and you can confirm its identity. There is one more option of multi-wavelength scanning in which you can scan your compound at different wavelengths Here we have an example in which we have done scanning at 3 different wavelengths, 205, 268 and 311 nanometer. And I can see from the image that I have got maximum response at wavelength 311 nanometer. This I can use for further analysis because it is showing highest response at this particular wavelength. Suppose if you do not have any information about your sample, you can scan it at different wavelengths, or you get better understanding of its absorbance wavelength if we are going for multi-wavelength scanning. Here is one example for quantification by Hptlc scanner. We have taken an example of cannabinoids which are isolated from cannabis, that is famously known as ganja or afu sample. There are different cannabinoids, but the principal one are THC, that is tetrahydrocannabinol, and THCA, tetrahydrocannabinolic acid. Now, when we have developed the plate and we have taken the image at 254 nanometer, only one wavelength is there. We could see band for THC as you can see over here. This is the band which represents THCA. But there is also a band of THC, which we have highlighted by using this straight line. At this RF, at RF 0.41, THC is there, but in image we are not able to see it because it is not showing any response at this particular wavelength, 254 nanometer. But when we went for scanning, our scanning range is from 190 to 900 nanometer. And as it is showing response in low UV region, it is showing response at 210 nanometer. We could see its presence. We have got the response. We have got the peak for THC. We could quantify it, as well as we can simultaneously quantify THCA, which is showing response at 285 nanometer. This is how, by using scanner, you can check the response even which are showing low UV range. Now, many a times your compound may not show any absorbance in UV or in fluorescence, or although it is showing some response in UV or fluorescence, you want to go for confirmation of your results. Whether the band which I have got for, say, for example, routine is routine only, or it is something else. You want to go for additional confirmation, or it may not show any response at all in UV or fluorescence. In that case also, you can go for derivatization. Derivatization is a process in which, by using some derivatizing reagent, we add chromophore group to that compound and we make it visible. For that purpose, derivatization is done, and we have Camac derivatizer, which works on piezoelectric principle. That means this is the nozzle in which we are supposed to put our derivatizing reagent. The derivatizing reagent is converted into a fine mist, and then it is sprayed onto the plate uniformly. Only 3 ml reagent is required, 3 to 6 ml for 20 by 10 and 20 by 20 centimeter plates respectively. On the back side of the instrument, there is one bottle which contains 70% ethanol, and whatever extra vapors which are generated in this closed hood are collected into the waste bottle, and entire operation takes place in a closed system so that the analyst is not exposed to the toxic vapors of the reagent. This is how it is a green technique. Now, many of the derivatizing reactions, they are not complete without heating. That means thermochemical activation is required to complete the reaction or to give it color. For that purpose, we have this plate heater. They have given these grid lines with which you can align your plate properly. The surface is resistant to all the chemicals and the acids which are used in preparation of derivatizing reagents, and plate gets uniform heating throughout the length. Temperature range is 20 to 200 degrees Celsius, which is enough for most of the derivatizing reagents. And as we get uniform heating to entire plate, we can go for quantification and derivatization and further validation studies, even though it is showing its presence after derivatization. This slide represents different class of compound detection. After derivatization, you are aware that there are many secondary metabolites are present in different herbal samples. For example, alkaloids, anthracines, bitter principles. We can go for their identification by using this derivatization technique. We have set methods and set mobile phases and the set derivatizing reagents, which you can use for the analysis of these compounds in your sample. For example, we have drag and drop reagent, which is used only for identification of alkaloids. We have NP reagent, natural product reagent, which is used for identification and analysis of flavonoids only. This is how you can go for further many different class of compounds by using this derivatization process. Now we will talk about Hpt Lcms interface. Nowadays, chromatography can be coupled with spectrometric techniques by means of Hpt Lcms interface, which elutes pure Hptlc fractions into MS for confirmation and characterization of synthetic compounds, phytopharmaceuticals, food samples, herbal samples, organic samples, in any organic sample. It is suitable for any MS and HRMS which is commercially available in the market, and it does MS of selected fractions only. Suppose you have separated your compound on your plate, you have got good resolution, and now you want to go for its identification. What I have separated on my plate, you want to know that. In that case, you can couple it with mass analyzer. For its entire operation, 3 units are required: Hplc pump or Hptlc pump in standalone mode, Hptlc MS interface, and mass analyzer. Here there is laser crosshair. This is the piston to bring the instrument in extraction mode. We have this cleaning button to clean the system. This is the knob with which you can adjust the pressure of nitrogen or compressed air, which is required for the pistonic force. There is a 6-port valve for connection of capillaries from LC to MS. And this is the lever to bring the instrument in extraction or bypass mode. This is the stage on which you can keep your plate. You can align it properly as they have given scale on this stage, on this laser crosshair, and bring this piston down so that there is this extraction head is there in this region. It will come down and you're supposed to bring this lever to the front position. When you are bringing it in front position, what will happen is a solvent from the HPLC pump will come in contact with your sample, and then it is sent to the mass analyzer. You are supposed to wait for 2 to 3 minutes until you observe some signal or some base pick. Once you observe some signal, you are supposed to stop the operation by pulling the lever in the back position. And most important is sample only analyte and diluent is sent to the mass analyzer. It will block that particular region. It will take silica as well, but the entry of silica particle is blocked by means of this frit. This is frit which blocks the entry of silica particles, and only analyte and your diluent is sent into the mass spectrometer, which will give you this M by Z ratio, which you can use for identification of that particular band. So this is how it works. We have one example of how we have used this Hptlc interface for the identification of one of the API, that is tadalafil, in one of the Ayurvedic sample. There is Hptlc USP chapter 2251, which mentions the use of Hptlc interface for the identification of API in herbal sample. We were suspecting that tadalafil was added in one of the Ayurvedic Rasayana sample. When we developed the plate, we could not see any response, or the response is there, but it is showing its presence in very low UV. We are not able to see it at 254 nanometer. Therefore, we have highlighted it with the with these blue arrows. The sample band is over here, sample and standard. We wanted to have confirmation whether it is tadalafil or something else. So when we send the sample to mass analyzer by means of this Hptlc interface, we could see same M by Z ratio for standard tadalafil, and for the same band which is showing its present Ayurvedic sample as well. So this is how we could interpret, or we have confirmed that yes, tadalafil was added in Ayurvedic sample by using this technique. This slide represents Shimadzu and Chrome joint poster, which was presented in ASMS conference in USA. In this, characterization and isolation of quinones was done from Tectona grandis leaves. Hptlc part was done in our lab, and further mass studies were done in Shimadzu lab, and this was presented at this conference. Now we will talk about Hptlc method development and validation. Method development is very simple. If you have enough expertise, you can validate, or you can develop the method in 1 to 2 weeks. You can go for the validation of the same, and you can perform all the validation parameters as per ICH Q2 R1 guidelines. Specificity, precision, accuracy, linearity, LOD, LOQ, ruggedness, all these parameters can be performed by Hptlc. This slide represents various books, websites, which you can use as a reference for your particular analysis. This is the image of Hptlc Association, in which they have developed more than 270 methods for different herbal for different plants. This is the image of CAMAG website. They have developed several application notes, not just for herbal samples, but pharma samples, forensic samples, food samples. You can register free of cost on these sites, and you will get access to all these methods. And these are different books which you can use for your analysis for various samples. Now we will see applications, especially in herbal field. As Hptlc is a diverse technique, it has applications in many different fields like pharma, food, botanicals, industrial analysis, forensics, cosmetics, but our focus will be on botanical applications. Here is an example of identification of Vitex Nugundo, which is used for its anti-arthritis property. They have developed the method, and you can see from track 1 to 4 they have applied standards agnuside and Nugundoside, and from track 5 to 13 there are different samples of Vitex Nugundo or chestnut chest tree leaf. They have developed the method for the identification of the same. This is one more example for Vidania somnifera Hptlc fingerprint, which is commonly known as ashwagandha. And they have used leaf samples as well. You can go for the differentiation of root and leaf sample, or whether the sample which you are using is authentic or not. That you can analyze by using this method. Hptlc can also be used for differentiation at species level. Here we have one example, that is Garcinia is the genus, and 3 different species are there: Garcinia indica, Gummigatta, and Mangostina. And you can see all these species are showing different band pattern. If you see track number 2 to 4, which is there for Garcinia indica, then we have these tracks 5 and 6, which represents Garcinia Gummigatta, and track number 7 to 9 represents Garcinia Mangostina. You can see we have got different band pattern or different Hptlc fingerprint pattern for all these species, and this is the band for Garcinol, and below this Garcinol band there is one more band which is present only in Garcinia indica. So this is how you can develop method for that particular species, and you can use it for its identification. This is one example of polyherbal formulation. They are very difficult to analyze or separate. We have this formulation which was prepared from 8 different plants, Samangadi Churna, and our aim was to identify and quantify gallic acid from this polyherbal formulation. We have separated gallic acid at RF 0.41. We went for spectral identification. We have confirmed its identity, and this is the calibration graph with which we could quantify how much amount of gallic acid is there in my sample. We can also develop the method for simultaneous identification and quantification of different standards in sample. This is example of ginkgo biloba, which is very famous Chinese medicine, which is used against various for its various activities like anti-cancer activity, immunomodulator activity, antioxidant activity, and it has these four markers: gingolides A, B, C, and bilobalide. They have developed simultaneous method for identification and quantification of these four markers in one of the in this for this sample ginkgo biloba. This is the calibration graph and the chromatogram which we have obtained. We can also go for quantification even after derivatization. As I have mentioned, some of the compounds do not show any response in UV or in fluorescence. They can be made visible by using derivatizing reagent. In this case, we have used anisaldehyde sulfuric acid as one of the derivatizing reagent. We have derivatized the plate with this reagent and we could see separation for beta citosterol. In this case, we did not even know the name of the plant, what plant sample has been given to us. But still we have developed the method. You can see that we have got very good separation for beta citosterol. This is the calibration graph which is plotted automatically by the software, and this is how you get final result. 68.73 mu G beta citosterol is present in 100 milligram of my sample. This is one more example of quantification of artemisinin in Artemisia annua. One more example for identification of synthetic API, nimesulide and diclofenac, which was suspected to be added in Ayurvedic tablet. We have got separation for nimesulide and diclofenac at RF 0.5 and 0.7, and we have got same bands in tablet sample as well. By taking spectra, we have confirmed its presence. Hpt can also be used for quantification of adulterant. Here is an example of curcuma aromatica. When you have curcumin, bismethoxycurcumin, and we have used pure adulterant sample as well, which does not show any presence of this band, which is coming at this lower RF. But this extra blue color band is there, which is present only in curcuma aromatica or the adulterant sample. We have purposely prepared different blends at 10%, 25, 50, 75, and 90%. When there is 50% adulteration, you can see that this blue colored band is there, which is coming from the adulterant, as well as this band is also present, which belongs to this methoxycurcumin, is also present when there is 10%, as well as this intense band which is coming from the authentic curcuma longa sample is also there. So this is how you can go for identification and quantification of different adulterant by using this method. Steroids in herbal, this is the method for identification of different steroids in herbal formulations. And one can go for stability studies as well by using this technique. There are two approaches: fingerprint approach and quantification approach. What you can do is you can develop the method for the fresh sample, then you can expose that sample to different stress conditions as per your requirement. Then you can take out all these samples which were exposed at different stress condition and use same method as you have developed for the master batch or the fresh batch. And you can look for the band pattern, band intensity, and number of bands. If you see any change in band pattern or intensity has been changed, you can say that yes, my formulation or my sample, it's had started showing some degradation. In this case, we can only say that it started showing some degradation, but we cannot say that what exact chemical changes are happening in your sample. If you have knowledge about its marker, you can develop the method for quantification. Here you can see that we had one formulation and we developed the method for the quantification of the same curcuminoid, gallic acid, boswellic acid, and gingerol was there in this formulation. In 2008, if you compare the values, when we have done the analysis after 1 year, you can see there is decrease in the amount. In 2008, it was present in 0.98%. In 2009, after 1 year, you can see decrease in percentage. That means it has started showing some degradation. One can go for antioxidant analysis as well, which is very much popular nowadays. For that purpose, DPPH reagent is used. Once you do that particular analysis, you can see this purple background on the plate, which is because of the DPPH reagent, and you can see these colorless bands are there, colorless or yellow colored bands are there, which represents antioxidant activity. There is something in these bands, maybe phenols or flavonoids, which are showing antioxidant activity. That means you can say that the band which is present at this particular RF has antioxidant activity, because it is showing change in color, or it represents the compound which is showing antioxidant activity. This is an example of analysis of cardinaloids from Calotropis procera. Different reagent is used, KD's reagent. So these were some of the examples or the analysis which you can perform for herbal samples. Now let us take a look at some of the proud moments for Anchrome. Dr. Vandana Gawande, she has won Euro 2000 scholarship at Hptlc International Symposium, which was held in Berlin in 2017. Hptlc part was done in our lab. This is one more gold prize winning poster at Hptlc Symposium in Bangkok in November, which was held in November 2018. Miss Yugandhara Patil, she has won the award. And with this, I would like to share Anchrome's philosophy that we are technologists, not traders. We want to keep your system running. It is not the case that we will sell the system and we will run away. No, we are there to help you at every step. Whether you want our help, analysis related, method development related, you have got stuck in between, or you want any service related support, we are there to help you at every stage. And we are doing this from last 40 years. This is our image of our newly expanded Anchrome Hptlc Research Center in Mumbai, from where we give unlimited support to our customers. You all are welcome to visit. In this lab, we have Chamax, latest Chamax software and instruments. We have separate set for instruments for training and analysis. We are a group of 14 to 16 analysts, including 2 PhDs. We have separate set of instruments for hands-on training, and we encourage PhD earn and learn stream, wherein you can pursue your degree and at the same time you can do job simultaneously. Lab is available for your publication work if you are interested, and we provide Hptlc education webinars with live demo. So with this, I would like to thank you all for listening and your valuable time. Now the session is open, or any instrument one more time. I'm ready. I would be happy to help you all.
Thank you, Dr. Manjusha. The session is open for discussion. Students, if you have any doubts or clarifications, you can ask.
Or if you are facing any connection problem, you can type your question in the Q&A box.
We have one question, Doctor. Can you check the chat box?
Okay. Yes, so there is one question from Rohan Saxena. My question is, why is baseline correction is necessary in different analytical techniques like UV, Hptlc and Hptlc? Yes, baseline correction is necessary because if baseline is not stable, you may get interference from the impurities or the bands which are not required for your particular analysis. Suppose if you are working on curcumin sample and you are interested only in curcuminoids or bis dimethoxycurcumin, but you may get lot of interference from the other bands, or the interference might be from the electronics, or there might be some impurity which is coming from the solvent, or it is there from the plate. To remove all these interferences, baseline correction is required. I hope I have solved your query.
Any other questions?
Okay, what is the meaning of GLP compliant? See, when you are doing any particular analysis or you are using any particular instrument, say for example, HPLC, Hptlc, it might be any other instrument. It should comply with the regulatory norms which are set by the authorities or the guidelines. Uh, you should do analysis properly with proper instrument. The proper instruments should be calibrated. You should have SOP for that instrument. You should follow all the parameters which are set by the regulatory guidelines. If your instruments and the methods are compliant with all these, then in that case, you can see that, yes, my instruments are GLP compliant, good laboratory practices. Its long form is good laboratory practices. I'm using some instrument for analysis. It should give, suppose I have developed one particular method, on the next day, or if any other analyst is performing same analysis, he should get same results. He should follow same conditions. So this is made sure if your system is GLP and GMP compliant. Any other question?
I have a question. Am I audible?
Yes, yes, ma'am. Please.
Yeah.
Go ahead.
Actually, in the automatic chromatogram development under the under the humidity control, it was mentioned.
Sorry, ma'am, your voice is breaking.
Am I audible now?
Yes, yes.
Is it clear now? Okay.
Yes, yes.
So in the automatic chromatogram development,
Yes.
under that there was one parameter saying humidity control,
Okay.
USP approximately equal to 33%.
Yes, yes.
I did not understand that.
Okay, I'll explain you. Suppose even though we are doing one particular analysis, although we are working on same sample, we are following same method, but still we may get variation in the result. Because HPTLC is open system, we do not have control on humidity which is present in air. Although we are performing same analysis, same method, same sample, but I'm doing that analysis in Mumbai and I'm performing same analysis in Gujarat, we may get variation in the result. Suppose I'm getting RF value of 0.34 in Gujarat, I may get RF value of 0.40 for the same sample. This is because we are developing method in TTC chamber in which we do not have control on humidity which is present around that particular in that particular lab. To avoid this, United States Pharmacopoeia says that you should do the development under controlled conditions. That means you should have control over development or the humidity which is present in the air. Now, how we can do this? We can use ADC2 automatic development chamber in which they have given one jar along with that instrument. In that we prepare a saturated solution of magnesium chloride, and before going for development, the plate is continuously exposed to the saturated vapors of magnesium chloride solution so that the plate is exposed to the controlled conditions or the vapors of the magnesium chloride. It will give you same result after development. If I'm getting RF value 0.34, if you are using ADC, same results, same resolution for your sample. That is why they say that use saturated solution of magnesium chloride, do the development under those control condition, and then only you will get reproducible results.
Yeah, I understood. Thank you, ma'am.
Any other questions?
And then not just MgCl2. Using a variation, you all or you use
I think we lost Dr. Manjusha connection.
sorry, due to some connection problem, my connection got lost.
Yes.
Yes. Any other question?
Questions? If no more questions.
Yes, if you have any other questions, if you may strike it later. You can send your questions at lab@anchrome.in. We will revert you back with the answers.
Thank you so much, Dr. Manjusha, for sharing us your knowledge and experiences for Hptlc with the students.
Yes, sir.
Thank you so much.
Yes, thank you, sir, for giving us an opportunity to present this webinar, and we will be happy to deliver more such presentation, or we are ready for more future endeavors.
Sure, ma'am. Thank you.
All your students are welcome to visit our lab.
Yeah.
We provide free training on every first, third, and fifth Saturday of every month.
Okay.
And as I have,
we will let the students know. At SISTI also, we are using the CAMAC Hptlc also.
Okay.
For our analysis.
Then it's not a problem.
Yeah.
Okay. Thank you, sir.
Thank you so much.
So with your permission now, can I leave this webinar?
Yes, doctor.
Yes. Thank you, sir.
Thank you. Dr. Amrutraj.
Yes, sir.
So sorry for the delay.
No problem.
Students, we will continue with our next session for the day. We have Dr. Amrutraj with us. He is a product manager offering 14 years of industrial service at BIIS Laboratories, Delhi. So yes, Dr. Amrutraj has a PhD in chemistry from ICT Mumbai, and he's also did in masters in marketing managers from Jamanlal Bajaj Institute of Management Studies, Mumbai University. He also has a junior research fellowship, TEQIP under World Bank, senior research fellowship also TEQIP, and senior research fellowship at PepsiCo, best product manager Life Science Group India, and Star Club Award Biorad India, and Star Club Elite Award Biorad India. So with this short introduction, I invite Dr. Amrutraj to deliver his lecture on. Doctor, you can.
Yeah. Can somebody enable me for sharing the screen, please?
Just a minute.
Yeah, thank you.
Yeah.
I hope my screen is visible.
Yes.
That's the most common thing used nowadays with the online thing happening. Yeah. So good morning, participants. Okay. So just thank you, sir, for the kind introduction for this. My name is Dr. Amritraj. I'm the product manager in BioRad, based out of our head office in Gurgaon. Just to give you a brief on the topic per se, we'll be covering some of the principles, instrumentations, and applications with respect to Hplc, MS, GC, GCMS. Just to start off the proceedings, the company which I represent, I'll just take a couple of slides on where I come from and what are my company ethics and what are the things. I come from a company called BioRad. BioRad basically has an inherent things of advancing scientific discovery and improving lives. It's basically a 70-year-old company into life science research and clinical diagnostics, spread across 150 countries, having more than 1 million customers across the globe, having close to 9,000 employees and having more than 10,000 products with an annual revenue of more than $2.5 billion. Just to give you a brief, we have multiple locations of manufacturing, research, and R&D across the globe. Our headquarters basically is in USA, San Francisco. We have offices and R&D centers and manufacturing across Europe and Asia as well. India, we have multiple offices, head office in Gurgaon. Coming to the global leadership, we are looking at the thing of sustaining development or sustaining this. Looking at, for example, not only creating the products, but also the packing and those sort of things which are environmentally friendly and long-term sustainable. So we are making our designs in such a way that it produces less waste and those sort of things. And to partner in terms of, we are been partnering with educational institutes and universities. We have a dedicated division we call EDU, that is Educational Department, where we have kits and instruments, for example, isolating DNA from your cheek cells, which can be used in forensics. Those sort of things and curriculum which we have mastered over the past 20-30 years with the scientific education, trying to encourage young students and trying to increase their awareness part of it. In terms of service point of view, world leaders rated amongst the top 3 companies with respect to the service across the board with best technical support. And that is where we pride in ourselves in terms of having an employee satisfaction and getting best talent from the universities and colleges. Just to give you a brief on what BioRad is distributed into, before we get into our actual topic, we are basically 3 divisions. Life science research, wherein the product groups or which I belong to, have chromatography, electrophoresis, imaging, protein assays. We have something called a diagnostic group, wherein, for example, people going in for example, diabetic testing on HbA1c. It is done on a BioRad instrument using a chromatographic system. And digital biology in terms of it's a next generation of PCR for your high clone selection, those sort of things. Sorry, I'm just a bit, what do you say, my voice is not good, not keeping well, but excuse me for that.
That's okay.
Diving into our topic in terms of the Hplc, term Hplc. Now, what stands for Hplc? Just to give you a brief, some of you may be knowing it, some of you may not. Hplc stands for high pressure liquid chromatography. The MS stands for mass spectroscopy or spectrometer. Same goes for GC, which implies for gas chromatography, and GC coupled with MS called GCMS. So these are the broad terms used across industries, across academics for Hplc. We just had a session on Hpt Lc, that is thin layer chromatography, right? This is in terms of Hplc chromatography. Just to give you a brief on chromatography into our day-to-day life, the 5 everyday usage of chromatography, just I put a snapshot. Now everybody knows with respect to the vaccine, COVID vaccines, which we are done. Now, in terms of creating vaccines, chromatography step is an essential part of getting pure vaccines. We talk of Hplc, which is a small scale. When we extrapolate or when we scale up to liters and 1,000 liters of resin, getting lakhs and lakhs of vials of dosages, it is done on a chromatographic platform to purify the vaccines. So every day we are not knowing the term chromatography, but somehow it affects our day-to-day life. And that's the reason why I just thought of having this examples shown across. In terms of food testing, if you go, for example, to any food testing lab, Hplc or Gc along coupled with MS are being used to, for example, if the mut of the non-veg part is either from the chicken or something else in adulteration, that could be checked out with an Hplc or Lcms. Beverage testing, for example, we know about in terms of alcohols having, so whether they have any additional additives or those sort of things which can be adulterated, that can be done on this platform. Drug testing, for example, the athletes, have they taken any dope material, that can be done on drug testing. Forensics, basically in terms of whether anything has been poison, has been injected to it, whether those compounds are there in the blood or a urine sample of the dead person, that can be analyzed through an chromatography system along with MS. So these are the day-to-day examples where directly we may not heard a term like chromatography or this, but it affects on a day-to-day basis. Going forward, chromatography as such is not a new technique. It's basically more than a century-old technology or a technique. It's basically, what is chromatography? It's basically a separation technique from a mixture of compounds. As in, for example, if you have a mixture of grains, it may be a wheat, rice, you want to separate out individual grains of that. And those separation technique is called chromatography. This basically was invented by a Russian botanist, Mikhail, who in 1906, with the help of a calcium carbonate, that is a pure chalk, separated out the color of graphene from the leaves, plant pigments. And you can see, for example, chlorophyll, alpha, beta, though chlorophyll, we know chlorophyll, but it's alpha, beta, different variants of chlorophyll. And he separated back in 1906. It's almost a century old. So it's not a new technology per se or new technique. It's a century old technique, which has got a lot of advancement over the past century. And people have added on to it. Now, in terms of the definition with respect to the IUPAC, which is basically International Union of Pure and Applied Chemistry, where they do nomenclatures of the technique. Chromatography is a physical method for separating out compounds. Now, in the pictorial representation, you can see three color, basically yellow, blue, and red. It may be same. Now, basis on this, you can see the mixture being poured into, and this getting separated. Now you can see the yellow being a bigger size, blue medium, red smaller, and this getting separated basis on the size. So basically it's a mixture of compounds and getting separated, distributed between phases. What I call phases is, there are, I'll come to that, what phases are, but getting distributed over a period of time and individually collecting the each component, because that is where we are interested in, separating each component and analyzing the compound of interest for further use. Please stop me and ask questions if you have any. Now, the common features in chromatography are, for example, there are two immiscible phases. Now, what are immiscible? That is, it is not been dissolved. For example, if you take sugar and water, the sugar dissolves in water, right? So it's immiscible. But if you take put a salt pebble or stone pebble into a water, it does not. So basically immiscible. So that's the precise reason how chromatography works. So there is a stationary phase. That is basically, it can be a silica, it can be different resins, small particles, which is finer than the hair or in terms of those signs. And there is a mobile phase. The mobile phase can be a liquid, can be a gas, depending upon what the sample type is and what the thing is. So basically two immiscible phases. The sample mixture goes repeated interactions. So as I told in the previous slide also, the interactions is between the samples which is in the solution, also the stationary phase which is in the column, which is there in the glass column which is there. So it goes into repeated interactions. The interactions can be of a physical type, it can be of a chemical type, depending upon the technique, which we'll see a bit later. But that is a broad perspective. Now, each component, so if it's a mixture of 4 or 5, each component has a different interaction or the strength of interaction. It can be strong, it can be weak. So, and that is being exploited to differentiate or to separate out each individual component. So that is where it is. And component or the individual component which is interacting more with the mobile phase comes out faster, or it comes out from the solution or the column faster. And the component which interacts more with the stationary phase, that is what is packed inside the column, it migrates later. So that is where the separation happens. Okay, a differential movement, that is difference between these two, are the ultimate need for a resolution or a separation part of it. Now, how can chromatography be classified? The chromatography classified can be based on multiple aspects. One broad aspect is based on the mobile phase. Now, based on the topic, we are covering two types of chromatography based on just the mobile phase. That is the Hplc, that is the liquid chromatography, where liquid is the mobile phase, and Gc, where gas is the mobile phase. So this is the broader perspective. But if you ask in terms of what are the scales of operation, especially in terms of the liquid chromatography, we have scales of operation from analytical perspective, just to check whether the compounds being separated, what is the purity of the product. For example, whether it is 99% product, which is good for example, if I take a particular drug, maybe a paracetamol, maybe Calpol 650, or maybe something, whether it doesn't have any impurity to do a passing pass. So that is where the analytical aspect comes to it. Now coming to production scale and preparative scale, which I mentioned in terms of vaccine manufacturing, we talked about monoclonal antibodies, antibody treatment with the COVID perspective. Now those are produced on a very large scale. Large scale as in it might take the space of an entire lab. Bigger columns wherein in terms of 1,000 liters of the resins are being packed, and 10,000 liters or 5,000 liters of the samples and mobile phase are being produced. So those are the scales of operation, more pertaining to the liquid chromatography. Based on adsorption, whether for example the compound adsorbs or compound does not absorb, it bases on that. So it can be termed as positive chromatography or negative chromatography. And also based on the elution. Elution again bases on the mobile phase. You can have a common mobile phase or a same concentration of mobile phase, which can be termed as isoprotic. You can change the mobile phase during the run. So the change of mobile phase, for example, at the start of the run, you have two mobile phase. I'm just putting two as example, A at 100, B at 0. But at the end of it, end of the run, you reach A at 50 and B at 50. Both becomes 100. So that is called a gradient elution. It can be linear, it can be step gradient. Again, just due to the limit of time, we can just to give you a brief, but it can go into that parts as well, linear as well as step gradient. Now I've just showed this is just a peek how the chromatograms are recorded on a software, and that is where we come to know what are things. It's just a peek. So what are the important parameters which you will be coming across, or which you will be hearing, or which you may be getting trained into? What are the things? One is basically the retention time from the time of injection, for example, to the where the peak is eluted. Okay, once after the compound where the peaks are eluted. What is the corrected considering the void volume? So for example, if your column volume is an X, and if you remove that X part of it, what is the corrected retention volume? The peak height. So what is the height of this from the baseline? Somebody asked about baseline correction, right? In the previous class, previous lesson. Talking about baseline correction. So if the baseline is not, this is basically the baseline. If this not been corrected over, if the not been corrected over here, you may not get a pure thing. So you need to do a baseline correction with respect to analyzing the peak under curve. Peak width, usually if it should be a Gaussian curve, Gaussian peak. If the peaks are a bit wide, then you need to work on the process, or in terms, you need to work on the mobile phase or the column or the flow rate to minimize this, because we are talking about analytical scale and we need to have very sharp peaks. So these are some of the terminologies used in an HPLC, quite frequent, which just to give you a sneak peek, very essential for having it. So you might have retention volume, retention time, peak week. So these are the usual terms of graph. Now coming to components of chromatography. Now, because we are talking about principles, the liquid chromatography, the gas chromatography, which we'll be coming and we'll be discussing in more in depth. So what are the components of any automation chromatography? Now on the screen, basically you have seen some sort of an orange block, considering this as a column which can have, for example, it can be used in, for example, liquid or gas. Some particles are, for example, packed. These particles can be silica particles. This can be C18 particles. You might have seen or you might have heard C18 columns, which are generally used in an HPLC. So considering that as a column, so what are the additional components required for a system or for a chromatographic system? And this is not a new thing. Automated chromatography has been in the research and the industry domain for the last 5 decades or more. So it's not a new domain, but the essential part, you should understand what are the essential part. One is an auto sampler. Basically, the whatever samples you want to separate out, it can be a mixture of 2, 3, 5 compounds, individual compounds. It can be main compound along with impurities. You want to monitor what are the impurities. Basically, you need an auto sampler to inject the solution into the column. So that is called one component is basically the auto sampler. Second component with respect to the liquid chromatography is the pump. The pump is required to pass on or to push the solvent's mobile phase into the column. It can be isocratic. It can be 1, 2, 3 different columns or mobile phases into this column. So again, depending upon the size type which we select. So this is the second important component. For gas chromatography, instead of the pump, you have the gas. You have inert gas like helium. You have the inert gas like nitrogen. And with the pressure of that gas, it is used to pass on the thing. So, so that instead of the pump, you use the gas as a mobile phase, and the pressure with which the column and the sample moves in the column. In liquid chromatography, the liquid pushes. So liquid pushes, and then you get a separation. Now, once the compounds or once the individual compounds are separated, you need to detect what is being separated out. Now, detectors are of various types. It can be UV, it can be visible, it can be conductivity, it can be refractive index for your carbohydrates, alcohols, organic acids. It can be DAD, PAD in terms of photodiode electrode, photodiode detectors. So detectors can vary depending upon the application. But the essential point is you require a detector for detecting, and after detecting with the help of software, you need to analyze part of it. The fraction detector is essentially a part of a preparative liquid chromatography, not used in gas chromatography, but used in a preparative liquid chromatography. Just as in I told for vaccine manufacturing or for monoclonal antibody purification. And you need to collect, for example, milligram to gram level in a sufficient quantity. Then you require a fraction detector so as to collect those individual, either the vaccine or antibody, and further in terms of treating it for further in terms of it can be lyophilized, those sort of things. So these are the essential components. Okay. Any questions? Sorry. Yeah. So these are the essential components of any liquid chromatography. In gas chromatography, just instead of the pump, it is replaced by the gas or the pressurized gas, inert gas. Now, in terms of sensitivity of the detectors, the highest being the mass spectrophotometer or the mass spectroscope, and then comes the fluorescence, UV, conductivity, refractive index. So that there goes in terms of sensitivity. Depending upon your application, whether you are wanting to monitor very finite or minute quantities or minute amount of samples being detected in terms of sensitivity, you select the detectors accordingly. There are multiple vendors in this domain offering multiple not only instruments but also detectors depending upon the application. It can be, as I told, RI, it can be fluorescence. It's basically a pick and choose between the what your application or what you are looking at and selecting accordingly. Now we talked about the hardware or the components of basically a liquid chromatography. Now the important part where the chromatography happens, basically that is where the magic happens in the column. So what are the types of column which can be used or which are employed in a liquid chromatography, basically? Now, for example, chromatography, again, if I want to classify on the basis on the mobile phase or the stationary phase, these are the five, basically 5 or 6 types of resins or matrices which can be employed in a liquid chromatography. Right? It can be gel based or size. It can be ion exchange basis on the ionic character of the solute, that is your compound, as your resin. You exploit the ionic character, for example, of the compound. It can be hydrophobic interaction, basically in terms of what are the hydrophobic patches onto the compound which can be exploited. Affinity is just like a lock and key mechanism. For example, if you have a particular lock with only a particular key, it opens. So the same goes with affinity. Most commonly used affinity chromatography technique for biomolecule purifications are, for example, your nickel NTA. We call the nickel or histidine tag purification for your tag-based purification, and something called a reverse trace. So this is the reverse trace is the most commonly used technique in HPLC. This is most commonly used in your preparative mode for biomolecules. So as I told, gel filtration employs size of the molecule. This employs the charges, the hydrophobic character of the compound, ligand, for what are the ligands situated in the compound, mixed mode is between those, and it also this is basically a reverse trace, as in terms of applying the hydrophobic characters for small molecules more particularly. Now coming to Hplc and Gc. Now these two are the basically, as I told, separation techniques, and over the past 50-60 years it has got a lot of tractions with varied applications. We'll talk to the application in the last slide and where it can be used or where it has been employed on a day-to-day basis. But both in academic, industrial, forensic, you can there is no lab which or no academic institute or industry lab or in terms of a research institute not having a liquid chromatography or a gas chromatography. So it is widely used, widely employed technique. There are at least 7 to 8 known, well-known companies providing solutions for this space. Now, HPLC, for example, again, as I told, liquid chromatography. We can see these are some of the platforms for liquid chromatography used in pharmaceutical, foods, life science, polymers. There are many in terms of petroleum, what all industry it can be used for this. Gas chromatography usually employed for smaller volatile, semi-volatile organic molecules like hydrocarbons, alcohols, aromatics, as well as pesticides and steroids. So these are the a little bit more selective in terms of what can be used or what all the molecules or compounds can be detected with the help of gas chromatography. more in terms of use in areas of food safety, environmental testing, forensics, and in terms of industrial segments. So these are the two aspects and segments of industry, are the segments which can be are employing HPLC and GC on a day-to-day basis. So we talked about all the liquid chromatography. Now we'll just jump into the mass spectrometer or the mass spectroscopy, and how is the history of it. Mass spectrometry or mass spectroscopy is also an analytical technique. It's basically nothing but ionizing your compound of interest, and we measure the mass to charge ratio. And this is very important technique tool employed, especially in terms of high sensitivity, understanding what are the different fragments within the compound, how it is been broken, what is the abundance of each fragment, those sort of things. Again, if you ask what are the history of mass spectroscopy, again a century old, started off with Professor J.J. Thomson in physics with the first mass spectroscopy in 1906, followed by France, and these are all Nobel laureates for this domain of mass spectroscopy. Francis Aston in 1922 for the isotopes, maybe in terms of differentiating between if the number of neutrons are more, having in terms of those sort of things. Wolfgang Paul quadrupole is one of a different type of analyzer used in mass spectroscopy. He got a Nobel laureate trying to invent that, who invented that. And more recently, for example, Koshina Takanaka from Japan, basically he invented a MALDI TOF or MALDI, which is mainly used, again, a type of mass spectroscopy used for your large molecules, maybe in terms of proteins, biomolecules, which are huge, unlike your small molecules like your paracetamol or, for example, the diclofenac sodium we get as a painkiller. So, so those sort of things are being generated for very large molecules. So these are some of the well-known scientists who have contributed immensely to this technology in mass spectroscopy. Now, when GC or LC is combined with mass spectroscopy, it can not only separate out with the help of GC, but it can quantify, analyze, and identify unknown peaks. It become so why this is important is because sometimes, for example, some of the unknown peaks are there, and how do you elucidate the structure of it? Now this elucidation of structure is nothing but breaking down of a compound in terms of chemistry into small compounds and looking at the M by Z in terms of charge. And that is how you try to detect in terms of trace level of contamination or any unknown peaks. And you can be reviewing about this amalgamation of LC or GC with MS on enhancing your results on a day-to-day basis. Now, if you look at what MS in terms of the steps involved in mass spectroscopy or spectrometer is, basically this is an architecture of a mass, just a brief architecture, and there are basically 5 steps in MS to speak. One, once the sample comes from the chromatography instrument, be it a liquid or be it a gas, there is a step called ionization, which is over here. Now this ionization, the electron ionization is the most common technique using in MS. The samples are bombarded with basically the electrons coming from the heated filament, and that is where basically the electron runs into the stream of cathode and anode over here. So that is where the first step of MS comes in terms of the ionization. Second part is acceleration of these ions. So basically acceleration, there are 2 charges in terms of cathode and anode over here, and the ions are accelerated, and there is a slit cut in from this. So the ions will get repelled by one plate and be attracted by others. So these are accelerated in this stage. These are all compact in the instrument, but just showing you an architecture of how this MS works in a graphical representation. Third is the deflection with the help of the magnetic. So the lightest gets deflects most, the heaviest get deflect the least. Okay. So basically this deflection is being used. So there are different in terms of analyzers used for this deflection. It can be quadrupole, it can be triple top. These are there in my subsequent slides, but those can be in terms of used. But in a broadly, the deflection happens for the mass, and in the end, basically the detection. So detection, basically the ion stream falls on basically a wire, and on hitting the wire, it becomes neutralized. And basically this M by Z, basically the charge has been recorded on a chromatogram. And if you see, for example, a two-dimension or two chromatograms. So for example, the red being the chromatogram of the liquid or the gas chromatography, and this being a mass spectrum, the retention time, as I told you, from the time the sample gets injected, and the M by Z, the charge mass to charge ratio of each peak has been recorded. So that is where you get in terms of not only having the compound separated, but also identifying each structure or each compound, what is the structure about. And that is where this combination of LCMS or DCMS has given it much fillip to the research and industrial use to not only understanding, but also analyzing and getting to a structure point of view with this technology. Now, again, just to a deep brief on the components, just I explained earlier, the sample introduction, the source, the analyzer. Now this analyzer, that is ion sorting of in mass, can be of multiple types. It can be quadrupole, it can be time of flight, that is TOF, we call it TOF, or magnetic sector, electrostatic, triple quadrupole, ion trap, ion cyclotron. It can be different. So most of the manufacturers have all, some of them they have multiples. It can be triple QTOF, we call the QTOF, quadruple TOF. So those sort of things are there. Again, each analyzer has a different type in terms of the separation of the ions basis on the complexity of the origin or complexity of the molecule you are looking at. I'm not going to detail of each one of it, but just to give you an idea. So these are the different type of mass analyzers are there in MS. So with this, basically we try to cover what is HPLC with GC, what is MS. Now we go to in terms of the instrumentation part, what all things are there in, for example, the liquid chromatography and also the MS, how things are coupled. I mentioned about basically the components of chromatography, that is the auto sampler, basically the pump, the column and the detector. Now this is basically a more graphical representation of HPLC is. I'll show you an examples of what HPLCs are in terms of day-to-day basis, but just to give an example. Now these are the liquid, for example, this is for HPLC, liquid as in liquid phases. We have something called a degasser. Degasser is basically the vacuum pump. It removes whatever dissolved oxygen is there from the mobile phase. So this is essential part, because if the mobile phase or the buffers has oxygen, it may in terms of hamper on the chromatogram coming in. Basically, this is a recorder or a computer where you analyze that. So it might hamper on the peaks which is coming in. So that's the important aspect where you get with the help of vacuum, you degas it, then you mixing. With the mixing, you inject into a column. There's a steel column which you can see, detector and recorder. So this is how the injector can be manual, it can be automated sample. So this is how the system architecture looks with respect to the HPLC, and how it looks on a day-to-day basis in the labs. For example, these are something called an HPLCs into for analysis point of view, these two photographs. And this basically is a liquid chromatography. I'll not call high pressure. So liquid chromatography, but on a production level. I told about analytical and preparative and production level. There's something on a production level chromatography. These two are nothing but, for example, instrument, liquid chromatography, but for biomolecules. In terms of, it can be proteins, it can be enzymes, those sort of things. So it can be of different. So these are the usual setups you see in the lab on a day-to-day basis for the liquid chromatography setup. Now, if you take a step further, we talked about LC. Now we are talking about LC coupled with your MS. Now, in terms of MS, so this architecture remains the same for the liquid chromatography. After the column, we get analyzed with this, and there is something called the Lcms interface. And then you have the 5 steps in terms of ionizing, in terms of then you have the heating part of it, basically in terms of accelerating, then you have the deflection and detection. So that is in terms of the 3 phases of the MS gain recorded. And then you have a chromatograph. So every instrument has a different chromatography or the software which can detect the chromatogram, and then you can analyze accordingly. On a day-to-day basis, this is how your Hplc, Hplc or Lcms is almost the same thing looks like. For example, we have this called a TOF, that is time of flight detector. This is called a triple quad, that is quadrupole detector is there, and this is the LC in terms of the liquid chromatography. Again, in terms of application, we'll come to see what applications this all do. This, for example, the ion trap. So multiple things. So this is how you see on day-to-day basis when you come across in terms of the labs, academics, industries. This is how the setups are usually stacked up for this LCMS or HPLCMS platforms. Now coming to instrumentation for gas chromatography. Now auto sampler, chromatogram detector all remains the same. Instead of the pump, you have the innate carrier gas, which is nothing but the mobile phase. Most commonly, it is used basically either the helium or nitrogen is used as a mobile phase, which is pressurized. Some traps are used just to purify or to remove unneeded elements or particles from the gases so that it does not harm the instrument. So some traps are used to avoid whatever unnecessary things going into the instrument. Sorry, excuse me. Then you have the outer sampler, same component. You have the inject, then you have the columns. These are basically capillary columns, very fine columns. Then the detector, chromatogram, and your computer. And if you couple with GCMS, for example, now for example, the same, you have the GC coupled with MS. So this is how your GC looks like. This is how your GCMS looks like. In terms of it's just putting together 2 instruments with an interface in between, so that there is an interface between the GC and MS. So once it detects after GC, it goes into the MS part of it. Now coming to applications, which is the most important part, where all this can be employed. Now, if we talk about forensics, I don't have any in terms of data showing where it has been in terms of, I have not, because of wanted to show you different aspects rather than data of each individual applications. For example, forensics. Now, everybody or some of you might have heard about, for example, the case going on for the Sudanda Pushkar or Shashi Tharoor, wife of MP Shashi Tharoor. Now, for example, they were in terms of, there were talks about poisoning and things. In terms of forensics, the use of drugs or the abuse of drugs can be detected through an HPLC in this. So where these sort of instruments are used in forensic labs to detect any particles which cannot be which can be carcinogenic or which can be harmful for the person, or which can maybe, or which is the cause of death if injected in sufficient or toxic amounts or high amounts. So it can, those can be one of the key applications. Blood and urine, as I told, for example, you heard Olympic just got over last year in terms of we have our gold Olympiad, gold winning Olympiad from Haryana. So basically their blood and urine samples are tested. Why? Because they the WADA, that is the World Anti-Doping Agency, they want to check whether these athletes, they don't take enhancers or enhancing or performance enhancing drugs just to enhance, because it would be an unfair competition. And again, to analyzing the blood and urine, HPLC, GC coupled with MS are being used on a day-to-day basis. So this is in terms of broadly where these applications can cater in. Now in terms of environmental and wastewater, for example, we talked about the water testing, for example, part of it. Are there any in terms of either municipal corporations, in terms of the pollution boards, whether you have a lot of industrial areas, they have sewage water treatment plant. In terms of the pollution board, the soil analysis, whether anything, any organic compounds are there. For municipal corporations, before the water has been released for drinking water or it comes to our taps, what are the organic compounds there? What are there any volatile compounds? So those sort of testings are done either for the environmental purpose or in terms of the pollution boards. So again, broad application, but these are the small things. Again, you can segment into further part, but I'm just captured all the broad perspective of the applications with respect to the environmental part of it. Biopharmaceutical. Now, biopharmaceutical, as I told, it's pharmaceutical attached with bio in terms of biomolecules. It can be your proteins, it can be your antibodies, your vaccines, your monoclonal antibodies. We heard about monoclonal antibody treatment for COVID, right? Because these sort of things. So these are been either analyzed for their purity, or basically they are being employed on a larger production level for getting the pure antibody drugs. Or in terms of you have the protein analysis part of it, in terms of whether you want to check the protein is pure or not, which can be used as an injectable. So in biopharmaceutical, again, Hplc, Hp along with Gc is, and Ms is being used on a day-to-day basis. Now, if you go to biopharmaceuticals or any pharmaceuticals, there would be at least 10 to 100, starting from small to high, 10 to 100 instruments in just sitting in one unit, and they are testing the compounds on a day-to-day basis. For example, each batch they test whether, for example, they want to test whether instability studies, whether if particular drug is been kept. We always, for a drug we kept, for example, iska expiry date kya hai? What is the expiry date of that drug? So they check for how do they check the expiry date? So they keep the drug in, for example, 2 years, 3 years of accelerated degradation, and then they check what are the impurities which is formed, and that is how they, with the help of dissolution studies and assays, coupled with your chromatography and GCMS and Hplcms or LCMS, they come to know, yeah, this is my shelf life, or this is my expiry date of the drug. So these are the studies which been done not only in biopharmaceutical but also pharmaceutical industry per se. Food and beverages, again, a very key industry, a key segment where this technology is being used in terms of pesticides. We heard about there was 4-5 years, there was a lot on hue and cry about Maggie, sort of what are the things which is there in the Maggie, the pesticides being there in Coca-Cola. How it has been analyzed? It is with the help of either the Hplc or GCMS. So those compounds, basically whatever sample is there, what are the unknown or very minute quantity is been analyzed with the help of these two platforms, so the LCMS or the GCMS. Food additives, for example, whatever the adulteration takes place, whether it is within the prescribed limit, for example, the color part of it, for example, the preservative part of it. If you see any packed food, there are certain quantity of preservatives, for example, 0.01 or preservatives added. So how it has been analyzed with the help of this technology. So and in terms of veterinary drugs, so in this this aspect also has a wide application in food and beverage industry. Pharmaceuticals, as I told, in terms of chiral drug analysis, is just like I'm assuming basically people know what are chiral, but just to give you a brief, if you hold a right and a left hand together, though if you superimpose, it is different, but if you hold it together, it looks the same. So it's the drugs are also like that. One structure or one one form will be active, the other form may not be active. So that's the reason why in pharmaceuticals, Hplc is being used with the chiral drug. A particular chiral drug may be active, a particular form may not be active. So hence, to remove that, pharmaceuticals, Hplc has been used quite extensively. And lastly, in terms of either the textile testing, whether suitable compounds, any bleaches are there, which may be causing rashes, or whether they have been washed properly, any reactions are there, those sort of things. In terms of industrial, as I told, municipality corporations or sewage disposal, what are the any harmful toxic chemicals are there before it has been discharged either to the sea, or in terms of the sea or the river streams. So those sort of things are being monitored with the help of HPLC. So these are broadly what are the applications which an HPLC, LCMS, GC or DCMS can cater. Depends, for example, the molecule to molecule, compound to compound, and also what are the complexities which you are looking at. That will decide what type of analyzer or what type of chromatography one needs. But broadly, this encompasses what are the applications which are there. There are numerous examples in terms of papers showing different aspects, but I'll not go into detail. It will be difficult to justify putting all things in a very short point of time, but I've just summed up for this. So that with that, basically, I conclude. I hope I'm just on time with respect to the time at just 1 hour of the presentation. Here is my contact number. You can, so if anything, clarifications, any questions which needs to be restored, we can restart. And right now the floor is open for questioning part of it.
Thank you, Dr. Amrutraj. The session is open for discussion. Any clarifications you need to ask, you can ask. Any questions? No questions from anyone?
I guess people have understood, or they have not understood at all.
Yeah, all of them are undergrads, so maybe this is a.
So I just tried to put briefly what all things are there, not going into more technical, but yeah, that is what.
But this will help them to develop their project proposal, which they will do at the end of this workshop.
Sure. So that was the objective of having.
Yes, that was the objective.
Yes. Anyways, my contact number is there. I'll just flash it again in terms of if you want to put any.
I will share with them in the.
Sure. So feel free to let me know in terms of reach out to me if there are some assistance required on an individual basis. Please feel free to let me know.
Sure, doctor. Thank you so much for joining us today.
With your permission, I'll just take a leave.
Okay. Thank you.
Thank you.
Students, we'll proceed on with our third session for the day. Dr. Ekta Kapoor. Doctor?
Very good morning. Am I audible?
Yes, doctor. Yeah. So for the third session, we have with us Dr. Ekta Kapoor, Scientist F in the Department of Science and Technology, Government of India, and is the head National Good Laboratory Practice GLP Compliance Monitoring Authority of India. She is a doctorate in pharmacy. Dr. Kapoor has over a decade of experience in GLP compliance monitoring and is the lead inspector of National NGCMA. The committed and sustained efforts of Dr. Kapoor led to quantum growth and visibility of NGCMA and its activities. She has been instrumental in the rigorous exercise for attaining India a full adherent status to mutual acceptance of data in the OECD Working Group on GLP. Dr. Kapoor represents India in the meetings of OECD Working Party on GLP and has conducted the on-site evaluation of GLP programs of Canada, Japan, and Thailand. Dr. Kapoor's contribution to the activities of OECD's Working Party on GLP have been well recognized, and she is the Vice Chair of the Working Party for 2021 and 22. With this short introduction, I welcome Dr. Ekta Kapoor to deliver her lecture on good laboratory practice. The floor is yours, Doctor. Doctor?
Am I audible?
Audible now. You can start.
Okay, I have shared my screen. Can you?
Yes, visible. You can also go to full screen mode if needed.
I'm trying to do that.
Yeah.
Is that fine?
Yes, fine.
Okay. So first of all, I would like to apologize for some confusion that happened yesterday due to some connectivity issues. I could not check my mail, and so my lecture was rescheduled for today. But I would also like to thank the organizers, especially the team led by Dr. Murugan, who has been instrumental in organizing this wonderful series of lectures under Srishti, and trying to build up a level playing platform for all the researchers and students to understand what the requirements of the research in India and abroad in the coming years. So with this, I was listening to the previous lecture on mass spectroscopy, wonderfully explained by the speaker. And basically what all research in major types of chemicals, basically the pharmaceuticals and medical devices, what they need today is retraceability and reconstructability of the data, so that the data can be relied upon by the regulatory authorities. I would just like to explain that my lecture for today will be based on the quality system of good laboratory practice. And we have set up a national GLP, Good Laboratory Practice Compliance Monitoring Authority in the country in 2002. And since then, we have been working under the aegis of the international organization called the OECD, Organization for Economic Cooperation and Development. And I would take you through the journey of NGCMA, how we established the monitoring authority, how the procedures were built up, and where we are heading towards future. So the slide gives an overview of my presentation. I will speak about the regulatory framework. I will speak about the birth of GLP principles. What is the GLP quality system? Where is it applicable? What are the benefits of GLP? What is the mutual acceptance of data, or the MAD agreement and its benefits, of course, the NGCMA and its functioning, the status of India OECD today, the future plans of NGCMA, and finally, I would conclude. So if we all recall, the regulatory authorities in each country is responsible for grant of a marketing approval for any new drug, pesticide, cosmetic product, food or feed additive in the country. So all the data, including research data, pharmacology data, chemistry, manufacturing and control data, preclinical data, as well as the clinical trials data is submitted to regulatory authorities, which are government agencies for the grant of marketing approval. If we look at the process of drug discovery and development, the timeline for the drug discovery of single molecule is very large, up to 15 years minimum. If we start with around 10,000 compounds, we are just left with one FDA approved drug at the end of 15 years. If you count the number of zeros in the amount written, so it is actually too large an investment entry to start with a new compound, new molecule, or new chemical entity, NCE as we call it. And finally, when we get a new FDA approved drug, a lot of money, time, effort, everything has gone into the developmental process. So there is a need to be very sure that whatever data we are generating on any new drug is actually the data which can be relied upon. It is not cooked data. It does not have any manipulations, etc. If we go back in history, where did the regulatory data requirement begin? So we are all aware of the thalidomide tragedy of 1960s, which occurred in Europe, particularly Germany, where babies were born to females who had taken this drug, thalidomide, as a cure for the morning sickness that used to happen during their pregnancies. So the babies that were born to these ladies were actually having malformed limbs. And this was alarming to the entire world, that how come all babies born in a particular country are having some deformities in their limbs. At that time, the regulatory authorities went back to see what was the safety data generated on thalidomide. And to their surprise, they found that the safety data had not been adequately generated. And the drug had come into the market without being sure that the drug is safe to be taken during pregnancy. So at that time, a mandate was born for all manufacturers of pharmaceuticals, agrochemicals, industrial chemicals, cosmetics, food and feed additives to provide safety data in order to have their products registered or licensed. The safety data had to be generated based on tests or studies decided on by government regulators. So when the GLP principles, how were they born? When the thalidomide tragedy happened and the regulators wanted all data to be generated and submitted to them before a marketing approval is granted, there were a wide range of studies to be conducted. These included studies on microorganisms, in vivo studies on rats and mice, studies on non-human primates, environmental studies for agrochemicals and industrial chemicals, etc. When so many studies had to be conducted, there emerged a number of contract research organizations, or CROs as we call them today, with a claimed ability to conduct these studies. However, there were certain incidences, for example, the ones that happened at the industrial biotest laboratories in US, which showed that incompetence, lack of knowledge, and sometimes outright fraud reduced the value of results presented and put the regulators in doubt. So there was a need that there should be standardized, harmonized principles under which such studies should be conducted, and thus the principles of GLP were born under the aegis of the OECD. Coming to the definition of good laboratory practice, it is a quality system concerned with the organizational process and conditions under which non-clinical health and environmental safety activities are planned, performed, monitored, recorded, reported, and archived. This means that GLP is applicable only to non-clinical studies, and it does not cover clinical studies at all. So the samples for tox studies, mutagenicity studies, and even for analytical studies should be coming from preclinical or non-clinical samples. They should not be any clinical trial or human samples. Things, GLP ensures reconstructibility of studies. For that, the studies which are planned under GLP, they should have a written down document which is signed and executed by the study director of each study. And the study needs to be performed in accordance with the study plan and the standard operating procedures of the test facility which is conducting the study. The studies, all GLP studies, are to be monitored by a quality assurance unit, part of the GLP quality system. The study results are then recorded on raw data formats, which are issued by the test facility management, And the study is to be reported again in the form of a written document known as the study final report. And all study raw data, study plan, study report, and the specimens of the studies are to be archived for reconstruction of the study at a later date. Coming to the applicability of GLP, there are various chemicals or test items covered under this quality system. These include the industrial chemicals, pharmaceuticals, both human as well as veterinary, agrochemicals, cosmetic products, food additives, feed additives, medical devices, and some others like viruses. The areas of expertise for which a GLP certificate is awarded are 9 areas covering the physical chemical testing, tox studies, mutagenicity studies, environmental toxicity studies on aquatic and terrestrial organisms, studies on behavior in water, soil, and air, residual effects on mesocosms and natural ecosystem, analytical and clinical chemistry testing, and other studies to include safety pharmacology, DMPK, etc. The benefits of GLP include that it limits wastage of resources, it ensures high quality of results, ensures comparability of results, and promotes mutual recognition of results, thus helping to remove technical barriers to trade. How do we say that it promotes mutual recognition of results is that since the GLP principles are followed by all the OECD countries, as well as the mutual acceptance of data adherent countries. So a GLP study, which is done in a country which has a full adherent to MAD status, these results are accepted in all the 47 OECD member countries, as well as the 7 non-member MAD adherent countries. The main goal of GLP principles is to help scientists to obtain results which are reliable, repeatable, auditable, and recognized by society. That is, the quality and integrity of the studies conducted under GLP system are ensured. Coming to the mutual acceptance of coming to the mutual acceptance of data system of the OECD, the MAD is a multilateral agreement which allows participating countries to share the results of various non-clinical tests done on chemicals. It is again based on the simple concept of tested once, accepted for a second. The MAD agreement is composed of 3 OECD Council acts, namely the 1981, 1989, and 1997 Council decisions. Benefits of MAD are both monetary as well as qualitative benefits. By reducing the duplicative testing, as I told you, if the study is conducted in a GLP certified lab of a OECD member country, it will be accepted worldwide because of the quality system that under which it has been conducted, that is the GLP. So MAD ensures reducing the duplicative testing. It also helps to save millions and millions of rupees by reducing this duplicative testing, and also saves tens and thousands of animal lives by allowing the results to be shared by all countries on a particular chemical. Then the qualitative benefits include the governments are able to evaluate and manage more chemicals than they would if they were working independently. It helps to avoid any delays in marketing products, helps to reduce non-tariff trade barriers, helps in reduction in animal testing and the animals used for experiments, and also helps to develop technical instruments that improve the quality of chemical evaluations and regulations. Testing in compliance with GLP is done on the basis of 2 sets of documents. The OECD principles of GLP are dynamic documents with new and revised guidance and consensus documents being introduced whenever issues need explanation. We also have the OECD test guidelines, which are the technical guidelines introduced after many rounds of ring testing and discussions in all OECD. The important points to be noted here are that both the OECD principles as well as the OECD test guidelines are common guidance documents having global consensus. that ensure that the data generated is robust and can be relied on by regulators worldwide. This enables the regulators to take informed decisions which favor the population and the environment. Taking you through the history of GLP in India, the exposure to GLP in India started way back in 1991. At that time, there was no NGCMA, GLP Compliance Monitoring Authority of the Government of India. The Indian manufacturers were forced to depend on the foreign test facilities for generating non-clinical data, which led to major foreign exchange burden. Non-GLP data from Indian test facilities was an important technical barrier for international acceptance, and the Indian test facilities had to approach GLP monitoring authorities of the foreign countries like Netherlands, Switzerland, Germany, and Belgium for GLP certification. And this process was too expensive, yet limited the global acceptability of Indian data. So the Indian test need to have its own monitoring authority, and the need was of course felt by the government, and NGCMA was set up through a cabinet decision in August 2002 under the administrative control of Department of Science and Technology with the following objectives. So monitoring authority is to operate in accordance with the OECD Council norms, because the OECD is the international body for GLP in the world. Then the NGCMA was to grant GLP certification to test facilities by examining their procedures and practices, by conducting GLP inspections and evaluating the integrity of data and reconstructability of the GLP studies, and also to provide a network of GLP certified labs in the country for the regulatory authorities and assure regulatory authorities that data received from GLP certified labs can be relied upon. The slide shows you the functional chart of NGCMA. At the top, we have an apex body called the GLP Authority, which has the secretaries of Government of India, of all the stakeholder departments with whom, for the GLP certification. And Secretary Department of Science and Technology is the chair of the apex body. Then under the apex body, we have the NGCMA Secretariat in the Department of Science and Technology, where we have a secretariat working on the GLP applications from various test facilities. We process the applications, conduct inspections, and this is done through the GLP inspectors, which are trained to conduct GLP inspections by NGCMA itself. We also have a recommending body called the Technical Committee on GLP, which recommends whether or not a test facility may be granted GLP certification based on the inspection reports of the various test facilities. We have international linkages with the OECD Working Party on GLP, where end all their annual meetings. Currently, India, represented by me, is the vice chair of the OECD Working Party on GLP, and we would be the chair in 2023-24 of the OECD Working Party. Of course, we have a network of GLP certified test facilities. As on date, we have 49 GLP certified labs in the country, which provide for GLP studies to be conducted in various areas of expertise and various types of test systems and test items as per their own certificates. The journey of NGCMA from 2002 till 2010 was a difficult one. It was full of a number of pitfalls, but yes, we were determined to, develop our own monitoring authority procedures. So the compliance procedures were built, documented, and implemented. The first certificate, which was a milestone, first GLP certificate, was issued in 2004. We conducted training of our GLP inspectors so that they could inspect the GLP test facilities. We also sensitized various test facilities by inviting applications for GLP certification, and of course by certifying them after conduct of their GLP inspections. and study audits. We also organized a number of training of test facility personnel, and we were evaluated by the OECD through a mutual joint visit or an on-site evaluation, where we had a team coming in from the OECD working party to evaluate our documented procedures as well as the procedures of conduct of GLP inspections by the NGCMA inspectors. The evaluation was held twice, February 2008 and 2010. And based on the 2010 evaluation, on 3rd of March 2011, India was conferred with a full adherent status to mutual acceptance of data. As per OECD publication, Saving Costs in Chemicals Management, the net financial savings to governments and industry brought about by the MAD program for harmonizing the testing and assessment of new biocides, new and existing industrial chemicals and pesticides, etc., are estimated to be more than 309 million. This is a huge amount of money that the Indian government as well as the Indian test facilities gain because of India being a full adherent to MAD in the OECD. This also saves tens of thousands of animal lives annually. Just to reiterate, today India is the only country in South Asia to be a full adherent to MAD, and our neighboring countries, especially China, is not even a provisional member of the OECD as of now. So from 2011 till date, India has been participating in all the meetings of GLP. We have been attending various OECD's training courses for GLP inspectors, which were held in different parts of the country: Edinburgh, Switzerland, Israel, Japan, India, and South Africa. India organized and hosted the 12th OECD training course for GLP inspectors in Hyderabad during October 2015. We have been conducting joint inspections with regulators like the US FDA, US EPA, and the and study audits at the request of various regulatory authorities, including the European Chemicals Agency. We have been participating in the on-site missions of other countries like Canada, Japan, and Thailand. India is now designated as the vice chair of the OECD's Working Party on GLP for 2021 and 2022. The on-site evaluation of Indian GLP program is scheduled for 2022, and we are gearing up, getting ready for the on-site evaluation. Giving you the details of the Indian GLP program, the GLP certification in India is still voluntary in nature, and the test facilities have to approach the monitoring authority for certification. The GLP certificate is valid for 3 years, and the test facilities have to submit an application for recertification 6 months prior to the expiry of current GLP. The certified test facilities are subject to mid-cycle surveillance through a surveillance inspection, and NGCMA currently has all its procedures as documented procedures implemented through a documentation system. There are 21 procedural documents currently to cover all procedures of NGCMA with respect to compliance monitoring, conduct of GLP inspections, and administration of the GLP program. The slide shows you the various types of GLP inspections that we conduct in India for our applicant test facilities. These include the pre-inspection, which is the first inspection which is done for any test facility to determine the suitability of the test facility to undertake a final inspection. The final inspection is a complete inspection, including the test facilities as well as study audits of completed and archived studies claimed as GLP by the respective test facility. Once a certification is granted after the conduct of final inspection, then 18 months from the date of certification, NGCMA conducts a mid-cycle surveillance inspection for its certified test facility. A certificate is granted for a period of 3 years. So if the test facility wants to extend its scope of GLP certification within the 3-year period, it can apply for extension in scope, where scope inspection is conducted by NGCMA. Of course, after the expiry of the validity of the GLP certificate, a recertification inspection is done for another cycle of 3 years. And the surprise inspection can be done for any test facility by NGCMA if we receive a complaint or otherwise, some information regarding the problem that may happen in the certification process. So we can do a surprise inspection for a test facility. Verification inspections can be done for verifying the action taken report of the test facilities on site. And we, of course, do inspections at request of regulatory authorities like US FDA, etc. So I would just like to reiterate here that the GLP inspection process is a two-pronged approach. We do the lab or facility inspection covering the facilities, personnel, equipment, apparatus, materials, reagents, SOPs, and archival facilities. We also study audits for reconstruction of completed and archived studies. In addition to this, ongoing studies at the test facility are also inspected to enable the GLP inspectors to ascertain the skill levels of personnel and correctness of procedure. India had conducted an impact analysis study of the national GLP program after almost 2 decades of setting up of NGCMA. The objective of the study was to seek inputs from various important stakeholders, namely the sponsors, regulators, GLP inspectors, and members of NGCMA's technical committee on GLP. All the responses were collected, collated, analyzed, and the recommendations submitted as the way forward towards strengthening the national GLP program. Just taking you through the results of the GLP impact analysis study. So far, the Indian test facilities have conducted more than 6,000 non-clinical safety studies. These are valued at Indian rupees 7,800 crores, which is US dollars 1.3 billion. And this is a major step towards self-reliance in the development of new chemical entities in India. The program has a significant economic impact, in the absence of which the cumulative of these studies would have otherwise gone to GLP test facilities outside India for the safety assessment of molecules. Among the total GLP studies, 40 to 50% of the studies are taken for Indian sponsors, and of the 49 GLP certified test facilities, which include 3 government labs, namely the Toxicology Center at Naipur, Mohali, the CSIR lab RI in Lucknow, and again the CSIR lab of IITR, India Institute of Toxicology Research in Lucknow, are the 3 government labs. So around 48% test facilities are CROs, 24% perform only in-house testing, and around 28% perform both CRO and in-house services. Currently, the GLP certified test facilities in India collectively have the competence to conduct non-clinical health and environmental safety studies on 8 types of test items and 9 areas of expertise in 20 types of test systems, including both in vitro and in vivo studies. The enhanced capacity of Indian GLP certified test facilities resulted in excellent cumulative annual growth rate of 25.5% in the last decade, which was significantly higher than the comparative CAGR of non-GLP studies during the same period. The GLP test facilities have also created job responsibilities for various profiles such as scientists, managers, and technical staff. The GLP test facilities have employed over 3,000 people in these key roles. So our future plans, NGC undergone complete digitization. We had started with fully manual program of accepting GLP applications, fixing up the GLP inspections, generating reports, getting them considered by our technical committee, grant of certificates. And now the entire process of GLP application, conduct of inspections, and even grant of certificate has become digitized through a NGCMA portal. An impact analysis study already conducted, and we are working on the recommendations of the report. As India is now the vice chair of the OECD's Working Party on GLP, we are roadmap and evolving the OECD principles and test guidelines, keeping in view the forthcoming challenges, for example, risk-based assessments, data integrity, inspection of cloud-based softwares, in silico or QSARS model, and in vitro testing, etc. We are handholding with various non-OECD member countries towards establishing global standards of GLP and aligning their systems with the OECD principles. Currently, we are working with the OECD Secretariat to help Philippines and Indonesia to attain GLP standards. We are also handholding with various government labs in India to bring them at par with the international quality standards for non-clinical research. We are expanding the scope of GLP program to new research areas as per the mandate of World Health Organization, and we are dedicated to implementing a system of GLP certification of highest commitment to quality, which contributes to the dream of Atmanirbhar Bharat or self-reliant India. To conclude, this is my last to both the OECD principles of GLP and the OECD technical guidelines allows regulators to assess the safety and to carry out risk assessment of the new chemicals. The entire system of regulatory talks supported by OECD principles and the mutual acceptance of data system is geared to make creditable data available to regulators so as to enable them to assess the possible impacts on health and safety of humans and environment. Finally, to sum up, GLP is meant to ensure the protection of the public and of the environment. So safety is the best present. Thank you so much for your patient listening. I will be happy to take up any questions that you may have.
Thank you, Doctor. The session is open for questions. Any questions, students? There is a question in the chat box, Doctor.
I'm trying to get on to the full screen of this, but I'll just first stop sharing and just a minute, please. Yeah. Chat box, of course. Okay. To become a clinical research organization, from where can we get the license in India? See, clinical research organization, of course, will be a legal entity. It will be a company, and the institute or the company will be required to register with the registrar of companies at the first go. Then you will be required to outline what all activities you would be doing, with respect to clinical research organization, and all those approvals then you will have to take from various. Say, suppose you would like to set up an animal house. So that would require the required approvals for setting up the animal house or the breeding area. So you would have a building and how much space requirements, everything you will be have to follow up the guidelines set up by the CPCSEA, that is the Committee for Prevention of Cruelty to Animals, Experiment and Animals. So CPCSEA under the Ministry of Environment and Forest, that will be required. And based on this, any other, you don't need to get a license for opening a CRO. You need to have a registration as a company, as a legal entity with the registrar of companies. And then whatever activities you do, based on that, you have different regulatory authorities from whom you can get the required approvals and work under the same area which you want to do. Is that fine? Great. Any other question, please? Okay, you have asked how long do the pre-inspection and final inspections take. So basically, the application is received at NGCMA and it is reviewed at NGCMA for its completeness, as well as the applicability of GLP certification to the organization. So application review will take generally 1 to 2 months, and the pre-inspection is fixed thereafter if everything is complete. And the pre-inspection is a period of 2 days or 1.5 day. And then we give the observations of the pre-inspection. The test facility is required to take an action on each of the observations. And if the action taken report is submitted within the stipulated time, we give a period of 6 months for submission of ATR for the pre-inspection. And then the final inspection is organized. If you submit even early, the ATR will be reviewed and a final inspection will be fixed up. Final inspection generally is for 2 to 3 days. And after the final inspection, again, the action taken report on the observations of the final inspection have to be submitted. And if they are acceptable by the team, they are put up before our technical committee, and the technical committee during its meeting may recommend grant of GLP certification depending on the timelines. Am I clear? Any more questions, please?
Any other questions, students? Okay, I think no more questions. No more questions, then thank you, students. Thank you, Dr. Kapoor, for joining us today and giving students an overview about the good laboratory practice, GLC practices needs to be followed.
It was a pleasure. Thank you so much for giving me this opportunity to interact with the students. And I would encourage everybody, to have more insight into the various types of quality systems that are required nowadays for regulatory systems. Because the quality and integrity of data is first and foremost today in today's world, where we are looking forward for safe products to be brought for human use as well as safety of the environment. So with this, thank you so much and have a nice day.
Thank you so much, Doctor.
I would take your leave. Thank you, please.
Thank you. Okay, so we will conclude our day 17 today. Thank you for participation. Thank you all.